Welcome to Machine Tool Design Community. Today in this video, I am going to cover a subject that is blank development in bending dies. So guys, whenever you receive any kind of bending tool, that is it may be the L bending or C bending or any other kind of the wiping die, you have to first develop a blank, that is a plain sheet. So let's go ahead and study that in detail. So guys, I will show you, this is a 90 degrees bend. So whenever this sheets bend, the outer portion of the sheet expands and the inner portion of the sheet contracts, because of which the center line, that is, there is one part of the sheet which there is no change in the size of the sheet. So at that sheet we call it a neutral axis. This neutral axis is an axis where we have no deformation, that is, the sheet is exactly what it is needed. So this actually shift. Generally when the sheet is flat, every part of the axis will have the same length, but when this expands and this contracts, the neutral fiber of the sheet shifts outside. That means the neutral fiber will be somewhat, it will not be 50%, it will be either 40%, 30%, or according to whatever will be the criteria. Because of this, let's say example that I need to make a blank which is 100 mm. Okay, that is, but after bending there will be the shift in the axis, because of which I have to give a allowance, that this part will be given a bending allowance. Okay, so bending allowance is an allowance which need to be allocated in the blank, so that after my bending I will get the desired size as per the drawing. So this we have to incorporate in the design. So let's go ahead and study what is bending allowance and what are the formulas and how we can calculate the same and add it to our blank development, so that our tool or our bending tool gives the perfect part after bending. Okay, so let's go ahead with bending allowance. So guys, what is bending allowance? Bending allowance is the amount of extra material to be added to the blank, so that after bending we will get the desired size. Take an example, very simple example. I have a sheet in the drawing whose after bending it is take an example 50 or 50, right? So I have to add their bending allowance. So take an example, bending allowance is 2.31. So my blank size will be 102.31, that is 100 mm plus 2.31. So we can add bending allowance to our blank, so that after bending we will get the desired size. Now there is a simple formula for the bending allowance, that is bending allowance equal to A, that is angle, this angle, that is here it will be 90 degrees, into pi by 180, pi equal to 3.14, in the bracket R, that is R is inner radius, and K into T, that is K is the K factor, which I will be covering when I take an case study or example going ahead in the video, and T is the sheet thickness. So let's go ahead and study this bending allowance with a good example. Guys, before going ahead with an example, I would like you to go ahead in detail what is a K factor. K factor, remember I said you that there is a neutral axis which is shifted because of bending. So that is what a K factor is. That is a percentage factor, that how much amount the neutral axis has been shifted. So the basic concept is, if you go the standard chart of K factor for different material like aluminium, copper, brass, mild steel, there is a big chart, it is manufacturer's chart. You can even find on internet, and even I will post it in the description box, that chart. But for this, I am telling you, for this mild steel. For mild steel, K factor, that is mild steel CRCA or HRCA, if the inner radius is equal to 0 to thickness of the sheet, we will take it as 0.46 mm. If inner radius is equal to 0 to thickness of the sheet, say example T is equal to 5 mm, and if my radius is 5 mm, then I can consider K factor as 0.46. Now if my radius is not 5 mm and I have taken 8 mm, my sheet thickness is 5 mm, so the K factor for it will be 0.48. And if the radius is, say example, more than 3 times the thickness, that is 16 mm, or like 3 times thickness, 15 mm, right? So I will take 0.5 mm as a constant factor. So did you get this? This is a simple basic rule. You can get this chart on internet or any book, that is any tool design book. You can get that chart. That's the standard. It's not anything invention here. So 0 to thickness, that is 0.46. Thickness to 3 times thickness, 0.48, and 3 times thickness and above, 0.5. So these are the standard. You can find this in my description box of the video. Okay. So now let's go ahead with an example. So let's go ahead with an example where the sheet thickness is 10 mm. The inner radius are equal to 10 mm. Then 30 and 30 is my length and breadth of the bend. So let's put this thing in the formula, that is bending allowance is equal to angle, that is 90, into 3.14, that is pi, divided by 180, into r, that is radius equal to 10, plus k. K is 0 to thickness is 0.46 mm. So r is equal to 10. So I will take 0.46 mm into thickness, that is 10 mm. So my answer will be, bending allowance will be 22.91 mm. Now with this you can find the total length of the sheet required for your design. That is the blank length, that is the blanking die. So you will have A plus B minus bending allowances. So guys, with this formula you can calculate the blanking length. So now whenever somebody comes to you and asks me that, hey man, I need to make a bending die, so you will be having two type of dies. One, the blanking die, and then bending die. So you will be designing the blanking die as per your bending allowances, so you know the blank length. So you will be designing the blanking die as per your So you will be designing the blanking die as per your design, and then according to the same feedback or the same model, you can just draw you can just design your bending die. So these are the both parameters you have to understand. Okay. Remember guys, also if you are into a product design and you are designing something that is a bending tool or bending part, so here always think that this R is never less than your sheet thickness. Okay, so this R is never less than your sheet thickness, and this R is always added, so one sheet thickness, so R plus sheet thickness, that is 20 mm. So these two things you have to keep in mind, that the inner radius should not be less than the sheet thickness, and the outer radius automatically will add one sheet thickness. You can have more inner radius but never less than 1 sheet thickness. Okay guys, whatever formulas I have said and also the data required for the K factor, I will be posting in my description box. So we require two formulas, that is total length and the bending allowance. Both I will post in my description box, and also the chart where you can find the K factor for aluminium, brass or any other sheet metal which you are planning to design. Okay guys, if you like my video, please subscribe to my channel, so that whenever I am releasing some new video, we will be in touch. Also, if you have any question, feel free to contact me via personal messages. I will surely reply as per my availability. Okay guys, have a great design career ahead. Thank you.